Started now. So good evening again. Welcome to today's session, and we'll just continue with what we do today. So just a quick recap, right? Um, in the last class we introduced SQL as structured query language, the advantages that SQL have over Excel, and we talked about under that we talked about how SQL can handle large data sets, unlike your Excel, and for also modeling your data. We discussed in depth on what these things meant, talked about the how to how to we talked about DML, DDL data definition language, talked about data manipulation language and data query language. We also talked of how to set up create database. After creating database, how to use that database, and we thought of how to create tables. We're going to touch on it before we finally go into what we have for today, and how to insert values, and then how to select everything. I think those were, and then how to navigate through all of this, right? So we're going to create a table that we'll be working with for this class so that we can move forward. And so these are like, over here is my schemas where database and the tables are stored. So if I create a database, it automatically appear here when I refresh. So let's create a database. I'm hoping that by now we know how to create a database. So when you want to create a database, you just use the create keyword, and because the database we're interested in, say create database, and we want to name this database school GB. We talked about naming conventions. This is the right way to name, or if I didn't want to put this hyphen, I would have started this one with capital letter. But I always want to use hyphen, right? And if you do it like this, that's a bad naming convention because you're seeing it as two separate words. You have to enclose it into a kind of apostrophe. If you look at your keyboard, below your escape key, there is a small something like apostrophe there. That's the kind of thing you enclose it in if the name has space in between, else it will run to be an error and you spend time. So the best thing to avoid it is name it correctly. It's very important. So you create this database, and when I run it, it's created, it runs successfully. This is it here. If I refresh this place, this is it. So this is the database. We don't have any tables inside it yet, so that's why it's not. So because I have so many databases here, I'd have to indicate that I want to use this particular database, school database. And once I run it, if I create table, it automatically store those tables into this particular database, right? So now, let's create the table and insert values that we want to work with. So we need to create a table. I always like to add comments, create tables to work with. So now, we're having create table, right? You can see the difference between creating table and database. So this table is, say, maybe the student table, because inside the school database there should be something about the students, and we want to define the attributes of this. The attributes are like the column names. So to do that, open this bracket, and over here we have something like student ID, right? This student ID, we want it to be an integer, and we want it to form our primary key. We talked about what primary key means in the last class, the unique identifiers, and we put a comma. We also want this table to have the name of the student, So this name now is a result keyword in SQL, in my SQL. So whenever the colors actually separate them, the result keywords are colored blue, while other things are colored normal, like your normal black. So because it's a result keyword, I'll just add a D. It's not good to use result keywords as attributes because when you run it, MySQL will think that you're trying to run a syntax and it's going to be automatically wrong. So the best thing is once it's colored blue, you already know it's a result keyword. So find something else to use. So let's just give it the named, or you can use first name. First name, right? In this case, once, of course, a name is a string. Talked about what varchar means and what it means to give it a length. So we are giving the first name the length of 40, and you are interested in knowing their departments. Okay, so now before I continue, I'm thinking that I might move the time down. I really do not know. So please, anytime we're going to have class, because my things are coming up so unexpectedly. I'm going to share in the group if the time we brought down to 6:30 or 7:30, because I wouldn't want us to miss class because of me. So anytime we are going to the class is going to be shifted down to 6:30, I'll let us know ahead so you can always come up. So department, of course, the department is also a varchar. As departments are strings, not numbers. So can give them this. Then another thing, maybe the student score, what the student actually scored. So this score now, most times it's integer. There's a difference between integer and float. We talked about these things. I want it to be an integer. So if you notice that the integers don't have the length that we are placing them, we talked about all of this. So I will just run this to create this table. So this table is created if I refresh this, if I click on this drop down, it shows me the students table. Nothing is actually inside this table now. So if I select everything, select everything from students, right, and I run it, it's just going to give me the table structure. So this is table structure. We've not inserted values into it, so nothing is here. So let's insert values. We quickly do it so that it doesn't waste time. We insert values into, right, students, since that's the name. Now my SQL is not case sensitive. If I decide to write all of these things in small letters, it will still run. And we want it to be name in the order of first name, followed by the age, followed by the department, and then followed by the score. That's how we want it to be. So the values this time around. So starting from the first one, we said that the first name is a string, so we have to start it and close it in double quotation marks. So this is insert into. So the first name, let's say we have Mary Smith, and she's 22. 22 is a number, so no need. And the department, she's from mathematics department, and she scored 74, right? That's number one. The next person is Nena. Obi. Nena says she's 21 and maybe 19 years, and she's in physics department, right? So Nena scored 67, and I think we just insert 5 names and work with it for the want of time. So the next one is director, and maybe she's 20. She's from computer science. Okay, Nena says she's on duty. She's from computer science. She got 78. Then another one is we have Adakole Osman, who studied, maybe he's 23, studied mass communication, and scored 79. So I think we'll just leave it at that. And okay, I think I want this thing to follow a pattern. So what I'll just do is I'll copy what I have here, paste it, change the name. I'll copy here. I want them to have repeating departments because of the queries we want to answer. So the values you insert are purely based on what you are trying to achieve at that particular point, right? So then repeat for mass comm. Think we are left for mathematics. Okay, so the next data set we work with will strictly import them and just work with them. Okay, so I think we have something now. I'll go ahead and run. So it's saying unknown column age. So when we created, we didn't have age. What we have is just student ID, first name, department, and so I want you to have this so that we don't start. It's better. So now I'm trying to explain the error. The error is saying that unknown column age, right? So there was no age when we were creating the table. So if you look through here, you would see that there's actually no column age. So it's easier for us to drop this table and recreate it than deleting all these values and starting from the beginning to insert. So that's why I'm trying to like redefine the structure of this table because it's easier. So let's just have first name, have age, have department, and have school. So first name is Ivacha 20, integer, age is going to be an integer, department is going to be Ivacha, and score is integer. So what I would do, I'm going to drop table because if I run this thing now, I run this thing the way it is. Let's run it and see what happens so that you will see. So when I run this, it's also going to throw an error. The error is going to tell me that the table students already exists. We already created this table and we are trying to create it again. The only way to run is if you decide to rename this thing or you drop it. So in this particular case, the main thing is to drop. We talked about how to drop table in the last class anyway. So if you want to drop a table, just drop table, the name of the table you are dropping. In this case, is students. And when we drop it, it's dropped. So now we can now recreate, and it's created successfully, so that when we come here, we can delete this part. We don't need it. And then we can insert values. So now you can see it's inserted correctly. So if I come here now and select everything, let's see what we have. So this is all the values we just entered: their first name, their age, their department, and their score. So we are going to be working with this table that I've created for the rest of the class to do the rest of the whole things that we're doing, right? So this data set is actually small, but it's rich enough to demonstrate the core SQL concepts that we need. So we've talked about data definition language, which are create, alter, and drop; data manipulation, insert, update, delete; data query language for retrieving data, select. So we'll start with the select statement properly now. So you can see that for me to see the whole of this table, I use select. Selected everything. So every time when you write that, it means select everything. So after doing that, you use the from. So just like from is like a closure, an ending. You have to select it from somewhere, because in your database there might be more than one table. If you don't explicitly state the table you are selecting from, it's confusing, because if I have the students table and I also have the teachers table or lecturers table, and I'm saying select everything, where the database will be like, where am I selecting these things from? Do you want me to pull all the lecturers or all the students information? So that's why you need to like select from. So select everything from, and in this case is our students, right? And remember how to run. If you click this, it's select. So we've selected everything, and we can also select specific columns. If you wanted to just see the departments, the name, maybe you want to see the students and their departments only. So in that instance, you can also do select. So I like to use capital letters for my reserved keywords, just so that they are aesthetic to the eyes. Remember that SQL is not case sensitive. So this case, we're interested in selecting only the student's first name and their department, their respective departments. So we just make sure that what you spell is what you used. So we have select student first name and the department. So if I go ahead and run this, it just pulls. So it's not running the name, first name in the field. Like, where is it selecting it from? So we missed out this ending part. So we need to indicate where we are pulling the data from. So I'll go ahead and run it. So it tells me that my mathematics department, then will be from physics, Uche Loretta is computer science, Adekole. So you can easily just, this is what we mean by querying your data. So at a glance, you can see the different, what is it called? The different people, their respective departments, right? So what if we want to select the unique departments? If you look at this place, you have mathematics appeared 2 times. If this was a large data set, maybe in UNN now, we want to actually know if they pull out students' data, like maybe for people that wrote GS. GS is the general course, like GS is like English language. They pull out and they have their own records. So everybody, it's a general course, so meaning that everybody from the whole school writes that course, right? So now they pull the information the way it is here. So they are seeing students and their different departments. Now, because the departments are going to be so much and it's going to be repeated, because inside one department there might be like 30 students. So it's repeating, right? So now we want to just select the unique department. We just want to see like how many departments are comprised, like in UNN, how many departments make up UNN that wrote GS. We don't want how many students in each department. This one is telling us how many students and their respective departments. But what if we're interested in just the department uniquely, so that when we look at it, we say, okay, there's computer science, there's mass comm, there's this. You're seeing the different departments just like a list. So in that case, you use distinct. I'm trying to introduce what is distinct. That's why I'm telling all the stories. So you use distinct. Distinct is like, yeah, I'm distinct from you, you're different from me. Just give me a list of the unique things, not repeatedly, not them being repeated. So in that case, I could just say select distinct, and I'm talking about distinct departments in this case. If I wanted to say distinct names, I would have done that, but the names are already distinct. So we have distinct departments, and we are picking it from the students table. So I will just run, and these are the departments: mathematics, physics, computer science, and mass communication. If you wanted to see how many persons are in each this department, we would have still shown that, right? So um let's not run so fast. So that's for distinct. Now there is also how you do filtering. When we did in Excel, when we once we convert our table to our data range to a table, there's always this pop-up drop down. It's like if this was a column, there will be a drop down here where you click and you will see the contents, the distinct contents of the table. If you wanted to filter, you could have just selected the ones you want to see. Or there is also the option of filter and sort. I'm using Excel as an example because we just came out from Excel, so I think it's easier for it to relate to. So you could sort, you could filter in Excel. So how do you want to do that? Filtering, or you can use if statements. So in SQL, there are many things to do your filtering and aggregation. There is the where statement and there is the case when. Case when is resembling how if statements work. If this is true, do this. If this is not true, do this. Case when, case this is this, when this is this, end. So we'll still get to case when. What we'll do now is the where clause. After doing the where clause, I think before we do the where clause, let me talk about should I talk about it now? Okay, we'll do the count. I want this thing to be like kind of structured so that you can follow it just the way the Excel class was a bit structured. You know how to do this and put them together. So let's take it in a structural way. So let's deal with filtering. And how do you filter data? Use conditions, right? So filter rows by conditions. So if, for instance, we are answering the questions to students, we're interested in, okay, I have students, I and universities give the age limit of students to be 16 years. But we know that maybe there are students who are below 16 who joined the university, and university are trying to weed out those students. So they want to say, we want to know students who are older than 16. So you can actually then use filter and the where clause. Now, the data set we have, I think the least age there is 19. The mean age, we could just do it. We've not gotten to that part. Select mean age from students. So if I run this, it tells me that okay, the minimum age here is 12. Okay, so that would determine what I want to write now. So if the school says we want to see students who are older than say 20 years, students older 20. That's what we want to see. So you know that if I select first name, right? First name for the students so that we know them. Now, another thing to take note is that you need to be able to know the columns that are associated with each question that is asked. If you look at this question, it says students older than 20 years. So your brain, for you to know those students, is either you know their reg number or their names. In this case, we are dealing with names, right? And you are dealing with older than 20. So in this case, is age. So the two particular columns you're interested in, right? So if I select the first name, I will select age, and over here I select it from students. It will pull out everything for me, the students and their different ages. There is no filtering here. There is no limitation. Like this is the whole data set we have. But this case, we are interested in students who are older than 20 years. So that's where we now use the where clause to say where age is greater than 20. So if I do this now, I will run it and it will just pull out students for me where their ages are greater than 20. I will just have 4 students. I don't know if this is making sense. So that's what you mean like filter. You can filter on so many conditions, like many conditions. So now let's do another one. Say students in computer science. Right. So students strictly in computer science. Now you are dealing with two things, two columns. The students, that is the first name and their department, because it's the department that will tell you that whether they are in mathematics, computer science, or whatever. So I would still select the first name, right? And I'm selecting department, and we're selecting it from here. So it's also important for you to note that the where clause comes after from. All these things have a place. If I write this where clause before this from, it will throw up an error for me. So it comes after the from. Select from, then where. There's also when we start dealing with group by, order by, you see how all of them come after each other, small. So now we have select from, and we're interested in departments. So first of all, let me run this. So these are okay. There's nothing like department. What we have is department, not departments. So these are the students and the departments, but we're interested specifically for departments where it is what strictly computer science, right? So computer science, computer science, and remember why I'm enclosing it in this double quotation mark. It's because it's what is it called? It's a string. So we're having this error. Why? Let me run it and see what the error message be like. So it's telling me that you have an error. Check the manual corresponding whatever. Okay, let me use single quotation mark. It's still going to be the same thing. So I think this is the problem equals this. Oh, this is the issue. So we just spent how many minutes? Because we don't right away. Just the department. So that where clause was the whole issue all along. So where department is computer science. So we run this and we just see that the two people that are in computer science are Uche and Uchechi. Is anybody still on the call? Am I talking to my
Yes,
Okay,
you're on the top.
okay. I think yeah, the number is still there. It's not about the number. Are we following? Or it's not entering at all? Hello? Okay, Sarah says she's following. Can I hear from every other person? Um, Hello? I need to be sure that you guys are following so that I'm not talking to myself. All right. Okay. I think that's enough. All right. That's fine. So, these are like, let's use, okay, that's fine. So now we've compared where age, we've used greater than, right? So these are comparison operators. Greater than, less than, less than or equal to. I would have used less than or equal to would be something like this. Equal to the here. This greater than or equal to. If you want less than or equal to, I still write it. So this is like comparison operators. Then there are, instead of using signs like equal to, greater than, there are also logic functions. We treated and or during Excel. So it also applies here. When you say and, I mean that those two things are true. And once both things are true, I'm following silently. All right. So and using logical functions with where clause. Logic functions with where clause. So in that case, you have something like and, you have something like or, you have something like not, you have something like between. It's depending on what you want to do actually, right? So let's just take them one by one. So let's say we have select. That's a bit faster. Select everything from students. So students is all small letter. Yes, the class is being recorded. So select everything from students, and of course, for us to filter, we use the where clause, where department in this case is what is equal to mathematics. So I like to use double quotation marks just so I'm consistent. If you want single, start with single and continue. So where it is mathematics, and in this case, the score is greater than 70. So these two conditions must be met. If if it is not met, if it is not met, it won't run. So if you observe what happened now, I started with a double quotation mark and I closed it with a single one, and seeing all of these things as string because I've not closed it. So that's why I say you need to be consistent. You cannot start with single quotation mark and end with one. So these are small things that waste your time when you start writing queries. You spend your whole time trying to debug one simple thing, right? You just let's be tackling them here. So you start with double quotation mark, make sure you close the double quotation mark, use your and. So now this is a variable name, department, this is another attribute score. So these two conditions was met. It's not okay for that person to just be in mathematics. That person's score must also be greater than 70. If you're in mathematics and your score is not up to 70, it will not pull out your data. So you see how SQL does. So let's run this, and it actually put these two people's data. Both of them are in mathematics, and they are both their score is more than 70. So let's use the score more than 75. You would see that it will just pull out for this last person, right? So we run again. So you just put that for this John because it's only him that is in mathematics that his score is greater than 75. So that's how to use and. Can also do for, so or is like one has to, like if anyone is true, it will happen. That's how or is. So we have not. Not is a negation operator. If this is not true, do this, then this is true. So we have selecting everything from student, right? Where department is not equal to physics. So you can see the sign for notes. It's not spelled notes. It's actually this. So this is not. So where department is physics is not equal to physics. So it will pull out every other student who is not a physics student. So if you check through this department, you wouldn't find students who are in the physics department, right? So then the last one, between. So when you write between, maybe you are saying between 10 and 20. Actually inclusive. So if you say between 10 and 20, 10 will be included, 22 or 20 will be included. So I want to write inclusive, right? And let's say we have selecting everything again from students where age between. So you see why I say I like SQL? It's more like you're speaking English. Where age is between 20 and 22. So we have an here. That's because we did not coordinate this. Then we run it. So these are the people who their ages are between 20 and 22. Anybody whose age falls outside this bracket would not be included. So you can see that 20 and 22, those people whose ages are 20 or the dots were also included. So that's the between. So the last now to do about this, the different things, like since where is a filtering operation, different conditions that can be applied to where is like is like pattern matching. If this is like this, also bring it out for me. This is not like this, leave it. So let's see how it works. And here we are select everything from students where name. So now first name, right? Not name. Where first name is like. So now what if we just want to see all the people whose name starts with U? So I can just put this. So this one is for people whose first name starts with U, right? And we go ahead and run it. These are the only two people whose first name starts with U. So that's like, maybe you know people that, okay, you want to just see people, A candidates, because you know that when you're entering exam hall, you enter alphabetically. So you just want to first of maybe there are different exam hall. You want people whose name starts with letter A to be in this hall, next people with letter B to be in this hall. So in that case, you're going to print different attendance sheets and share it to different lecturers so that the lecturer that is handling hall A would just go to the database and print names with A. So they can just run this kind of thing where their first name is like you. So the database will just pull out those people whose name starts with U. They will be in one hole. You change this thing to M to pull out those who start with M, print it out. They will be in one hole. So I'm just trying to give you a real world scenario kind of um what happens in this case. So what if you have something like instead of starting, so if you observe, you see how it happens. So instead of starting, you want it to those who end with what is it called, A. Those people whose names end. So if the letter is before the what is it called percentage sign, it's before. When you if the letter comes after you're meaning those whose name end with. So we run this, and these are the people that their names end with A. If you don't want it to be just this, it can be as many as possible. TA, people whose names start with T, end with TA. This is the only person that her name ends with ETA, right? So you can include as many like patterns as you would want. And then what if the final case is if you enclosed it into two percentage sign? Yeah, meaning what you are saying. I think I should have just been doing this now, writing a comment. I'll do that just so this one is for contains ETA. Once it contains ETA, pull it out. That's what you're interested in. So I'll run it. It contains ETA, right? So I'll just say once it contains A, pull it out. So these are all the people that their names contains A. So once what it means is once it contains something, we've done for when it starts and when it ends. So I don't think that one's an issue. So this is like where we draw the curtain for where, right? I hope we are not lost yet. So I would also want us to go into sorting and limiting, right? So this one is like filtering your data sets. You have a huge data, but you just want to see a subset of your data. You use where conditions and its many use the where clause and its many conditions to filter out a subset of your data that you would like to work with. So this is it. So meanwhile, this particular thing that is filtered out, you can actually just export it. Maybe you filtered it, you want to export it. So you can click that export button from this your output. After filtering out a subset of the data you like, you can then just filter, like export it and go and print it out. So you can see it's actually it has real world meaning. Just it's not like you're just talking. So if this was actual student database where they have like up to 1,000 rows, like in computer science, before I graduated, my class we up to 300 and something students. So if my lecturer just wanted to see people whose name started with A, he would just use this where clause filter us. The output to be here. He can just export it from here. I can print it out and use it for whatever he wants to. So that's like how you just picture it in your mind, something like that. So now I want to talk about sorting and limiting. So when you talk about sort, it's different from filter. Filter is hide some, give me some. Hide the rest of the data, give me the ones that meet. When you talk about sort, you're talking about the descending order. Sort it according to alphabetically from A to Z or from Z to A, or sort it from the lowest number 1 to 100 or from the highest number 100 to 1, something like that. So by default, when you write, okay, let me not be faster than my shadow. So the first thing is like order by, right? It sorts your results Give me a minute. Okay, so I'm back. So order by sorts your results, and the limits, which we just said. Limit is like I want to see the highest score. I will limit by 1. First of all, order as by z descending, yes, so that you start from the highest score downwards, and then I will limit it to 1 so that the output will just pick out the first row. We'll see it here shortly. So limit returns only the specified number of rows. So that's for limits option for you. And let's start. So some questions using our data sets. So what if we're interested in the highest score? Sorry about. So we just don't want to put data. We want to put the data, but we want to see from the highest scores first, so that we know the BGS of the class, right? Those who are performing well in the class. So I'm trying to plug my system. Wow. So give me a minute. I'm trying to plug my system. Okay, sorry. I was trying to plug my system so it doesn't die before we are done. Okay, so I was saying that we want to sort the student score from the highest down. Student score first. So in this instance, you already know that we are interested in 2 columns, the name and the score, right? So what we are using, if I select the first name and I select the score, and I'm selecting it from here, I will just run it. So by default, it's I don't know, scattered, right. It just pulls the data set the way we entered it. Remember, we entered Mary Smith first, we entered Nena second, we entered this person third. So there is no order, right? So I can choose to order it the way I want to, and that's when you now start using order by. So if I want to sort this thing first, let's do sort. I want to order it by order by. That's a keyword, a reserved keyword in MySQL that shows how to sort, right? So first, let's say we want to sort by first name. That means it should run it. So now what it does for you is that by default, when you say order by, MySQL sorts by descending order. by default, meaning it will start from the smallest letter down to the A to Z. But if you want it the other way around, you will have to indicate it by writing ASC is ascending. So if you run it now, it will, okay, I think I'm mistaking it. ASC it's for running from A to Z ascending, and then DESC it's for the other way around, right? So by default, let me restate what I said. By default, it runs by ASC, ascending order. That means to run from A to Z. But if you actually want it to run from Z to A, use descending order. That's DESC. It's no big deal. And that's for letters. If it's for number, it's still the same thing. Once you do not indicate DSC, by default it will order it by. So now we want to order by score because we're interested in those who scored highest. Now we do not indicate whether it's ascending or descending, so it will just go ahead and order it from smallest to biggest. So it will start from smallest. The smallest person, the lowest score here is 67 and the highest is 79. But we were interested in from the highest down to the lowest, right? So we'll just put DESC to indicate that. So now it has done what you want it to do. But this question, okay, the question says highest scores first. So this is actually answering the highest scores first. Now, what if the question is actually the highest, like one person? Who is the highest person in all of this person? The data set is so large. Remember, what we're working with is small, so you can easily look through it. By the time you're working with millions of rows, you cannot easily look through it. So you can just use a simple line of these simple lines of query to just retrieve. So just want to see the highest student, right? So I'll just copy this thing because it's almost the same thing. I'll copy it. I'll paste it here. And the last thing I'll just put is limits. So I'll put limit 1. I'm putting limit 1 because I'm talking about one particular student who is the highest. So I'll run it and to tell me that Adakole is the highest and he scored 79. If I'm interested in the top 5 students, I'll put 5 and to run it. And these are the people who scored top 5. Adakole, followed by Uche Loretta, followed by John, followed by Ada, followed by Mary. So these are the highest top 5. You can limit by any number you want to limit by, right? Limit by any number you would want to limit by. This limit function is very important. Very, very important. And order, it goes handy. So before you can limit. Once you sort, you can limit. So you can take a look at how the syntax go. First of all, so always be from select from. Then if you want to do another thing, you want to do, start doing it. So you must always select from. Then all those things you want to do, you continue them. So you select from, now you order by, and you do the where, the limit. So as you are starting, maybe you want to actually put a condition, right? And you can just put where. So the beauty about SQL is that if it's wrong, it will show that it is wrong. So if I put this where condition here, where age, where score, sorry, because there's no whatever condition you are placed in here, you must have selected it from here. Your select statement. So where score is greater than 70. So if this syntax was wrong, this red arrow would have shown. What do I mean? If I cut this where clause and I place it after order by, it's wrong. Like the order is not correct. So if you look at here, in your mind, you already know, okay, why is this thing showing red? Maybe it's because the order is not wrong. So you can just remove it from here. I'm telling you, like, so you don't go cramming and trying to kill yourself by the order, like how to place the where before the order, before the limit. At least for now that you're starting out, is when you start constantly using it, it will stick to your memory that, okay, where actually comes before order by, group by actually comes, because there's also group by comes before this. Like there's a lot of things. So you don't start now to start clogging your memory. So it will actually just pull it out. So it's you can see what it does. Let's remove this condition first and run this. So it actually pulls out for data. Let's change this score to 75. So you can see the where clause was applied. These are scores that are greater than 75. That's number one. Number two, instead of if we decide to comment this order by out, right? Let's run it. You can see that it did not take cognizance of which like 79 comes first, 77, like it just scattered. This thing now is taking the structure of how you entered the data. But if you're interested in the order, okay, just give us scores, people who scored 70, above 75, and still order it so that if I take a look, I'm taking a look at an orderly record, you have to include this, right? And what if those who actually, like now, there are 3 people who scored above 75. I'm just interested in 2. I'll just limit it to 2. So you can see how to use these things depending on the question you're trying to answer. So I'll just limit it to 2. And then to just bring out 2 for us. So this thing is answering a lot of questions. Just these 4 things, and those who scored above 75. Right? If this was a school system, it would be those who scored above 70 because 70 is a mark, right? Then inside those who scored 70, please start from, those A, there are differences between A. There are some people's A's that are 99. There are some people A's that are 70 on the dot. So it's inside those people who scored A for me. Let me see those whose marks are higher. So the other bar is doing that. Now, okay, I want to reward them, but I don't want to reward all of those people. I just want to reward the first 50 people. So the limit will now work where I'll put 50. So it will limit if there were 100 students who actually scored A, that's from 70 and above. And I just want to reward 50. I'll use limit to pull out the data for those who scored highest, right? The first 50 people that whose scores are highest and are their grade is A. I don't know if I'm making sense, but I think that's like how to go about it. So any questions? Any questions? That's for ordering and limiting. I would like to go to aggregate functions. Do you have any questions so far? Are we even following? So it's important that you understand the underlying concepts behind these things, because it gets complicated when you start writing a whole lot of other queries. So I was actually working on something yesterday, and this is part of the questions I work with. So you get to do joins, you get to do where inside one inside you get to do subquery. Like it gets more complicated as time goes on, but how you would know which one to use if you understand the concepts behind them at this stage that we are, so that as you write more complex queries, you would know if you should use a where, you should use a group by, you should use like whatever order by. So if you have questions at this point, please don't hesitate to ask me. And so when we done with this aggregation, we're going to talk about grouping, group by, and having, and the difference between having and where clause is a very popular interview question. And after that, um, we do advanced filtering. I'm looking at my time. and then we'll do some practice questions and some interview practice questions too. I have this book where I have some popular theory interview questions. They'll ask you what is primary key, they ask you what is where clause. At least I should be able to, I'll ask questions from there on the ones we've covered so that I can expect your responses. So be gearing up for that. I think we used 10 minutes of our time to do that. So let's go. We have aggregate function. Aggregate function. So aggregate is like you're summarizing your data. So under aggregate function, you have your sum, average, count, minimum, max. So these things are like the simplest mathematical calculations you can have, just like you have in Excel. Right? In Excel, you have average, so it's not a new thing. So if like the way we have this thing now, we don't really know the number of students that we entered, or do you? So what if I want to know the number of students I entered? Just like how many students are in this database? 100. I just want to see it that way. So let me use the comments. So we have count of students that we have. So I can just select. So I'm using count because I just want to count it. So there's a difference between count, there's a difference between sum. Sum is add 1 plus 1, 2. Count is count students 1, 2, 3, 4, 5, 6. Right? So that's the difference. So I'm interested in counting the students. So I'll count everything. Now there is something that is called alias. So alias is, if I count, okay, before I talk about alias, let's just leave it at this. Count students from where? Count everything from students, and I will run it. So it will tell me the count of everything. Like this is the name now. It's 8. So there are 8 students that we entered. Now, this name is not descriptive enough. If this thing was, it will, if let's say I did count distinct, and I'm interested in departments, the distinct department that we have, and that we run it. There's supposed to be another closure, and I run it. So there's it's actually departments, not departments. So we run it, and it tells me that there are 4 distinct departments, right? Mathematics, physics, computer science, and mass communication, which are the 4 distinct departments that we had, right? Now look at this thing, the way it's appearing. Does it look nice? It doesn't really look nice. So if you would want this thing to have a custom name, you just like in Excel, you get to read the way you want them to be, right? So that's where you use alias. So alias is just like, I don't like how long this thing is looking in my output, so I just want to name it something else. I want it to just be like department, or distinct department, since we have department already in our column. So it can just be like distinct department. So when I run it, it will still give me the same output, but then the description of the column header will be the custom description that we used. So if you don't want to use this AS, you can actually just give a space and still write your column name. But that's like when you become conversant with it, so you don't confuse yourself. So it will still do the same thing, right? So whether you put AS showing alias or you don't put it, once there's a space, it already knows what to do. Now, it's not only the custom columns that you are creating that you can give alias. For example, again, if this student, the name of this database is quite long, that I'm writing a very complex query. The name is quite long that it's not every time I'm going to be typing out students. I can just put an alias to it to call it S, right? So that it's very useful when you are working with two tables. When we start doing joins, you would see this one I'm talking about very well. I just want to like talk about it. That is not only for custom columns that use alias. If you are dealing with 3 or 4 tables at the same time, you would not want to be writing the table names the way they are. Maybe they're very long. You can just use an alias like S for students. If it's your lecturers, you can use L, so that if you're now pulling data, it can now be like S dot name, S dot first name, right? Or you can now do L dot id. So what, we don't have this data set here, so it will not work. But I'm just trying to like show us what alias does. So if we had a student table and we had a lecturers table, of course, for them to work, we have to do a join. So when we get to join, you will learn how both of them, the conditions that make up for join. But if we are pulling data from 2 or 3 more tables, we can decide to give these tables aliases, maybe their first letters or their first 2 letters, in this case S and L. So now what it does is that this one will go to the table for students, put the first name, go to table for lecturers, put the lecturer ID, and to display it for you. So in that case, maybe you are looking at students and the lecturers that taught them, or students and their course advisors. Because when you're in school, like I'm trying to use UNN system. When you're in school, you have course advisors assigned to you for your first year. So each student many students can have one course advisors. That's ERG now what I'm talking about. So I'm trying to follow these things logically so we don't rush. So this is for alias, right? So just know that alias is to give a custom name to your data, to your column, calculated columns, your table names, right? So I think that's for alias. Yeah. So we are still under aggregation. This is just one of its counts, right? So the next one is average. I want to see the average score. So average is just, all of them are just the same thing. So you have select, AVG. So AVG is average. So what are you not averaging? You're averaging scores, right? So you want to know the average score of students. So you still give it an alias of average score, right? And we're selecting from students, selecting from the students table. So when I run this, you see that the average score of students is 73.8. That's actually a good one. Tells you that your students are actually doing well, right? So that's for average. You can average the age. So you want to know, okay, what are the age brackets I have in my class? So average obviously works for numbers because you cannot average letters. You can't do average of name, first name, right? Because obviously you can't calculate. You know the formula for average. So it's doing that formula in the background for you. The summation of all the numbers divided by the count of how many they are. So that's average. So you can do as average age. So it will display that, okay, on the average, people are in that university are 20 years. Meaning, if there are people that are below 20 years, they're going to be small. Like the age range falls around 20. So, let's say we want to also see the highest, not this one, highest and lowest score, right? So for us to do that, we simply use select max. So max is like highest, max score. We also want to select the mean score. We're selecting it from the students table. So we didn't give us, so it will just display them as max score, mean score. You already know what is alias, so on your own part you can add that, right? Then if you want the total score, right? You already know total score is sum. So these are like the aggregate functions that we have: average, sum, count, minimum, maximum. If there are things that fall outside these ones, you will not have to do it by yourself. If you're trying to calculate the profit and loss, of course you know the formula for profit and loss includes you doing what's it called, multiplication and addition. You have to now use the signs. Multiplication is asterisk, division is forward slash, and then get it. But these are like the custom aggregate functions that you have. There are other ones though, just like the most frequently used ones. So if you're interested in total score for mass departments, right? So we could just, first of all, let's get total score. So we could select the sum, of score, right? We are picking it students, from students, and to tell us that the scores of all the students amount to 591. Now, if we are trying to be more specific, total scores for students in mathematics department, what do you think we should do? Can somebody help us? If you are trying to be specific now, we are trying to be specific. We are not trying to put the total scores of all the students. We just want to sum the scores of people in mathematics. What do we do? Anyone?
I think we are going to use
Hello?
reducing function.
What do we do? Somebody say distinct. Why do you say distinct? What's your reason? Do you know the meaning of distinct?
Because we want it, I think we want a specific um, subject.
Okay, that's a valid concern, but unfortunately, it's not distinct, right? Distinct tells you uniquely students, it will list all the departments for you. Or if you do distinct score, to list the distinct scores like no repeated values. That's what distinct does for you. But this time around, we are looking at maths department alone. Out of all the departments that we have, the 4 departments that we have in this table, we just want to see the total score of students in maths departments. So who can go again? What do we use? No one is talking. There's a problem if nobody talks. So it means I've been playing. And I cannot continue because I need to know that what we are doing, that it's not about how fast we are. It's about how much, even if it's little, that we're able to do, that we understand it. So if nobody is able to answer why, when we've done, so I'm waiting for us to hear. Your answer must not be correct. Say that thing that is in your mind. Let us tackle it and share ideas. What do we use to just see people who scores of people in only what's it called, mathematics department? Hey, there's problem. Okay, so it's actually discouraging, and not even one person is making an attempt. Sarah, are you on this call? Okay, Sarah is not on the call. Nena is not active. Okay, Chukwu, Chimaijem. Okay, so I think that gives me the base of how we're working with. I would have to make it more interactive, asking questions to see people who are actually following. So the question is like, what what we just did now is for students, all the students. We are trying to filter for only students who are in mathematics department. So what we should use is where clause, because we are trying to filter for only students who are in department. So we are having where department equals this case mathematics, right? Then you close off. So this was what I was expecting us to do. So 561 score, 151 came from mathematics department. So it will help you to know top performing departments and the rest of it, right? So now, what if I want to see the average score for mathematics? For what is it called? Average score for students whose ages are between 20 and 22. Can anyone try attempt that? Average score. Think average score for students whose ages fall between 20 and 22. Average score for students whose age falls between 20 and 22. Okay, can someone help us? Average score for students whose age falls between 20 and 22. Anyone? Hello. What's happening tonight? Is that skill or hard? Let me hear from you, please. Is that skill that hard? Yes, very hard. Wow. Jeez. And here I was thinking that we are all following. Okay. So where did you stop following? I always say that if you are lost, like you don't understand them, just talk or just type. It's always the notification pops out on my screen, so I'll sit and stop. I've been just been running and running without carrying my people along. So where do we start from now? Because we've come a long way. Do I go ahead to explain what we've done so far? Because I would not like to continue since we are not really getting. There's no need to continue if the ones we've done nobody understands it. Because as we go, we are building on these ones that are done. This thing is step by step. As you go further, it gets more advanced. So if you cannot get the basics ones, there's no need to be running. So I think what I'm going to do. So let me hear from you. where should we start from? Should I start from the table database creation, what we did today, like run it down again, just for better? Network is very bad. I'm hoping to hear from people. Don't keep quiet, please, so I will understand your pain points. Where do we start from? Let's make it interactive. When I try to respond, select average score. Okay, because people just gave us the answer. Okay, it's actually correct. Yeah. So it means that she's following. Select average score from students where age between 22 and 32. That's correct. So for the rest of the others, I'm hoping to hear from you. Please don't keep quiet. Okay. So while we're waiting for others to respond, I will go ahead and run this query that Ogechukwu gave us, and let's see if it runs correctly. So it tells us that students whose age are between 20 and 22 is actually 75.75. The query is right, it's correct. So the rest of the others, network is very bad. Okay, so I'm not happy that you guys are not responding, right? I would not know how to come in. It's either you talk or that you're understanding and then answer questions, or you tell me you're not understanding and tell me where we should start with, so I will understand your pain points. You can unmute yourself and talk. This is an interactive space. Typing is going to waste your time. Just yourself and talk. We may not understand as we go, but watching recorded class again should help. You're working within a time frame, trying to make us understand with slowly pace. Just my opinion. Yeah, which is very true. It's true. You're trying to work within a time frame, but I'm of the opinion that it's not even about trying to get you to understand everything at once without you not understanding anything. Because I think that's the problem we're having with people not submitting the assignments now because they didn't understand what we teach in Excel and they didn't ask questions. And I know that I was constantly asking us to ask questions. The problem is us not asking questions. What we have to cover today is not much. So I think we're in a good space for today. I don't want to rush things. Okay, so I think that's where the recorded class comes to play, right? There's a lot of persons say they have to like go back and watch it for a second time. So if that is the case, then no problem. The class is being recorded. If that is the case, then no problem. I'm hoping by next class. In fact, what we'll start with in the next class is exercise questions. As I'm dropping the questions, I'm expecting back-to-back feedback. So let me hope that you go back and look at the recorded sessions, right? So once we start the next class, I'll start with exercise questions. Question. I'm expecting back-to-back answers from you guys, right? So let's just continue. Let's just um cover I think this sum is the last thing we are doing for aggregate functions. So the last thing I have here, we have that, right? So network is messing up with Army. Don't worry, the class is recorded, right? It's recorded. So let's touch on group by and having, and the difference between having and where clause. So okay, group by. So when you talk about group by, you are grouping your rows into categories. What do I mean? Let's say that in this data set that we have, right, we are grouping by departments. And okay, I think we should use an example. So what group by does that it arranges your rows into categories. Group this according to this. Group students according to their height. Those who are short stand in one line. Those who are tall stand in one line. Average students stand in one line, right? So like grouping them according to different categories that are obtainable in your data set. So just for an example, and then for having, before we go into the example, having, what it does for it filters. Is also a filtering um clause, just like your where clause that filters based on a condition. But having filters group after you do aggregation, right? So we've already talked about aggregation, the sum, the average, the count, the mean, max, and whatever custom calculation that you do. So now, if you want to, let's say we want to, like the aggregation we did here, the filtering we did here, we did age. We not really use this average. So what if we did average score? And we go ahead and run it. So I want to put this pane up so that we can see the output. So it's actually what's it called? It's actually where average score equals 75 or greater than 75. So it's telling us invalid use of group function because we've done an aggregation. So whenever you do aggregation and you want to use that your aggregated function to filter, you use having. That's the difference. You use where when like there is no aggregation that you've done, just like we had before. But for having, you must have done an aggregation and you are then filtering based on the aggregation you've done. So let's use examples to illustrate our point. So we have like count students per department. It's just like the example I gave. We want to know the count of students under maths department. How many students were there? Remember what? So there, when I'm answering a query, I like to look at the key words in that question. So I've seen count. I know that the aggregation function I should use here is count. Remember, there's count, there's sum, there are many of them. So with this thing, I already know that what I should do is count. I'm trying to tell you my thought process. So maybe it can help you. And now it's telling me that students per department. So I'm concerned with students and I'm concerned with departments, right? So if I'm counting, I'm trying to count in each department. In my mind's eye, I know that the result I should get is the column for department and the number of students in there. So I'm supposed to get two columns. Even before I write the query, I like to think about the output in my head That would help me to write the queries the way they should be. But it's also very important that you understand the question you're trying to answer. So now, first of all, we select the department because there should be a column for the department, right? So we select it. And then we are also doing a count. So we are going to count everything as, and we'll give it an alias as non-students, that the number of students that are in that department. And then where are we doing this from? We're selecting it from the student table that we've created. If we decide to run this thing now, let's see what happens. It's telling you that in aggregation query without group by. So once you do an aggregated this thing, you're going to complete it with a group by. So we have group by. We are grouping by department because we're interested in each department. So we run this and it gives us that in mathematics there are 2 students, in physics there are 2 students, in computer science there are 2 students, in math communication there are 2 students, right? Let's do another example. So we want to see departments with average score. So you can see another keyword, average greater than 70, right? So now, the keywords here is that I'm dealing with departments, number 1, and I'm going to group by those departments. But the condition has to be that the department that should be displayed, the average score must be above 70. So let's take it one by one. First of all, I have to display the department. So to display this department is select, call the department name, right? And you have to get the average score. You have to get the average score and you give it an alias of average score, right? And then where are we getting this information from? We are getting it from the students table. And then we are interested for each department. So we have what is it called? Group by. We are grouping by department. So before I do the final thing, I'm going to run it so that you see how it looks. So now when I run it, it tells me that mathematics, the average score of student in mathematics is 75.5, physics is 67, computer science is 76, math com is 77, right? Now, the question we are answering is telling us that we should just display for department with the average score that are above 70. So obviously, physics has to go. So how do we do that? We cannot use where clause. If we use where clause here, it's going to throw up an error for us. Where average score, because we've done aggregation, is greater than 70. Let's run it. So where clause, and then because it's where clause, it has to be before group by. So if you're going to do a where clause, it has to be before group by first. But then let's run. So it's throwing up an error for us because it says unknown column average score in the where clause, right? So now, if we really want to do the filtering we wish to, because we've done aggregation, the right filtering to use is having. So this question comes up very well. People ask you what's the difference between having and where clause. So where clause is when you've not done any aggregation function, while having is when you've done. So having will come. So the syntax is that you write having after your group by. But if you intended to use where clause comes before. So you can see the order, right? So now it has excluded physics for us because physics was 67, right? So with this having filtered, we selected the subset of the answer, and based on the condition that the average score must be greater than 70. So this is exactly wanted us to do advanced filtering where we have to combine a lot of conditions to filter, but we'll not go into that now. Let's answer some questions. I hope I see this book. Mm, just give me a minute. I need to search for the book so that we can take some questions based, like, I would like to hear us speak on some questions based on what we did in the last class and what we've done in this class. So I'm going to share the recording of the class. Meanwhile, if Nena is online, please, you can open the attendance group so that people will take their attendance, or the assistant. Jesus. God. Jesus. Hello, can anyone hear me? Oops, the video is paused. So can you guys hear me? Okay, sorry that I'm still trying to find these documents, but I will just go ahead and ask the questions, right? I think I've seen it. So the first one is here is okay, this is not it though. Okay, let me just go ahead with the questions. So what's a primary key? Anyone? What is a primary key? Okay, a unique identifier. And next question is set of colors that uniquely identifies. Okay, that's nice. Then we have the difference between having and where. It's hanging. I said difference between having and where clause. Hello? Okay. Where is used when there is no application. Having is when there is an application. Okay, so I'm really so sorry that I'm not able to see this document. When I see it, I'll send it to the group so that you can have it as well. We'll start with it. We'll also start with, so the next class is going to be like practical. I'll ask questions to drop the answer for me, like the query. If possible, have your system open so that you can be running it. If you run it, if it's correct, you post it in the group, right? So that's how we'll do at least for the next 15 to 30 minutes of us starting class on Thursday. We'll use it for that. Please go. I'm going to drop the recording this night, and I'll also search for the material and also drop it across so that we can all make reference to it. So I think that brings us to the end of today's class. Remember the CCB assessments. I'm trying to buy time for us, right? Because a lot of us mistook projects that we built for the assessment. It's different. This one is CCB that requested it specifically. The one I gave is for what you did in class. So it's important that you submit it because it's also one of the assignment that is recognized in terms of your certification. So you should do something that is outstanding. I don't know how I'm going to buy time for you guys, but I'll try to do that. So the deadline is on Saturday because I want to collate everything and send it to them on Sunday, please. So make sure that by Saturday night, you've submitted it in the assignment group. I would go together through it with Nenda and collect it. If you submit on Sunday, you might end up not being recorded. So please endeavor to submit by Saturday, right? Today is Tuesday. And thank you all for coming to today's class. Thank you all for checking up on me. Those who send their messages privately, I appreciate your kindness and reaching out. And I'm totally fine now. Thank you. So good night to everyone.
Good night.